Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So you joined me already in progress today. I wasn't originally going to film what I'm doing right now because it was storming outside really bad, but it is pretty much stopped and now it's just real windy. So hopefully that holds and we can actually record. So let me show you where I'm at. So last week we prototyped this piece here with 3 different 3D printed parts, and then once I was satisfied that we were good to go, I went and machined this out of aluminum. Also used some 3D printed spacers down here to figure out what was the exact length that we needed to square up the mounting head against this, this mounting bracket, and I have since machined those out of aluminum as well. I've also mounted the cover back here for the DRO that goes on the back, and I actually put a bead of caulk back here behind where it meets up against the casting so that any oil or cutting fluid that comes down here in the future will come down over this cover rather than sneak behind it. At least one person in the comments asked me why I mounted this so low, why so far down, why not come up higher so that I didn't have to make this bracket as stiff. And the reason why is because this is a gap bed lathe. This whole chunk of both the ways and the casting, if you can see up here, it's actually, if you can see the line, it's actually a different piece. You can take this whole piece out and swing a larger piece of material up here right by the headstock of the lathe. So this is as high as I can go. If you see, I've only got about 1 millimeter between the underside of this cover and the actual DRO rail that runs the length. So I couldn't go any lower with this cover, and this cover is basically that's as high as this whole stack up of parts can be. Otherwise, I would be into that gap space on the lathe. So for the DRO that's going to mount up here on the cross slide, where we had left off was I printed this piece with a 0.4 millimeter nozzle out of the nylon carbon fiber from Bamboo Labs, and there's some under extrusion on this. I just kept getting clogs with that 0.4 millimeter nozzle. I ordered a 0.6. I said last week I was hoping it was going to be here in time for this week. Well, it's Friday again, and it still hasn't come. But I want to keep moving with this, and if you see, the cross slide's already missing off of the lathe. I've taken it off because I want to get the holes drilled in it so that we can at least keep moving forward. Part of that moving forward is this cross slide exits off the back of the lathe, so you also need the cover back here that's sitting on my floor over here off the lathe to take the cross slide off, and I'd like to get that cover back on. So let's get the holes drilled in the cross slide, and maybe even kind of just mount things up with this to get an idea of where we're at for the lower mount that I can drill while that cover's in place. Ultimately, I'd like to get the cover back in place since all the work back here is done, and I can't use this thing till the cover's back on. It flings stuff all into my truck, which is normally parked here. All right, so where is the cross slide? Well, it is over here on the milling machine. All right, so over here at the milling machine, I've got the cross slide off the lathe, and it is already clamped down right to the table on the milling machine. And I've taped everything off because these are precision scraped surfaces down here, and when we drill and tap this, this is cast iron. Cast iron dust is abrasive. I just don't want that to get down into the surfaces and spend extra time trying to get that all cleaned up. And I've taped over the other side as well. And this is where this is going to mount. So this is where that bolt was that we were making our clearance here on the design. And this line here is, when I still had this on the lathe, I mocked up the height that we needed to be at, and then transferred one of our holes just into a mark up here to figure out where we need to be relative to this bottom scraped surface. And that works out to be 17.42 millimeters. I mean, give or take a bit. It doesn't have to be super precise, but that's, I'm trying to figure out exactly where the center of that is, and it came out to 17.42. Now, what I was about to do was to center up on our bolt hole here, and then, do half of our overall distance between our mounting points here in each direction, and drill and tap those. And unfortunately, I checked the back. Well, it's fortunate that I checked the back. Because we're right here by where the compound rest mounts and swings around on this cross slide. And you might note this other mark here. So I figured we can gain a little bit of extra ground if we move these mount points over even further. If you recall here, if we compare to the original aluminum bracket, I already moved these over quite a bit. And there's not a whole lot more distance to move them to, but we can move them a bit. And by the way, I put this one up on here. That's even worse. It's like almost dead center. Well, it's just past the center point on this side. So this one really would not have worked for us either. But I figured out I can go an additional 5 millimeters in this direction, an additional 5 millimeters in this direction on this guy. And we also don't need this much of a sort of milled or counterbore area for the screw to go into. The washer that's going to be underneath this guy here is nowhere near the diameter of that counterbore. So we can actually come an additional 1.5 millimeters. So basically we can do 6.5 millimeters further away from the center point for each one of these holes. That is what that line is, and I think that gets us over far enough where we should be okay. We don't have quite like this whole amount of material to work with because it's a T-nut in there. You can see that's the area that's cut, so the T-nut can slip in there. There's an additional 3 millimeters, milled up into this with like a T-slot cutter. But I did the math, and I think we have about 6 millimeters to work with. So I don't want to push my luck. I figure we can drill to a 5 millimeter depth at that point, and we should be okay. And I don't think we're going to hit anything on this side, although I should probably, I'll mark that and check before we do that. All right, so now that we know what we need to work around, the next step is figuring out exactly where these holes are going to go, because I did that just with a rule to get the rough location. But I want to zero out on this bolt hole, come exactly this distance that we need to, and we'll do the same thing when we come this direction to drill this one. And I also want to make sure that we are the exact distance that I measured away from this face here. So we'll use an edge finder to basically set a 0 against this surface here and set a 0 here. So that'll be our 0 in X, and the face of this will be our 0 in Y. And we're going to use the DRO to do that. Okay, so I've got a drill chuck in the milling machine here, and I've got just a countersink bit, and all I'm going to do is just use the hand wheels on the table to get underneath this countersink bit and use the quill to come down and just touch on it and get centered up on that bolt hole. All right, we're switched over to the edge finder. I'm going to turn the spindle on, and we'll find the exact edge of this bottom face. All right, I lifted that straight up off the part so we're clear of the edge, because now we're going to, let's see, that is the y-axis. We're going to zero that, but we're not actually at the edge yet because we're at the edge of the edge finder. So the diameter of this is 5.1 millimeters. So we need to move this direction 2.55 to be at the center of this. All right, now we are directly over, or I should say the spindle is directly over this face. All right, so I'm going to get the edge finder out. We'll get the drill chuck and a center drill installed back in here now. All right, got the drill chuck back in and the world's smallest center drill. So we want to drill 17.42 millimeters away from this face for up here. So we've got to move to 17.42 in the y-axis. All right, we're at 17.42, and before you guys yell at me down in the comments that each one of these measurements I'm not actually dead on, it's because these are 5-micron scales on this milling machine, so the closest that we are going to be able to get to 17.42 is 17.421 in this case. And we can actually zero that because both the holes that we want to drill in this are 17.42 millimeters away from this face. So let's go ahead and just zero that. Now for X, we want to, our holes are now going to be, with the additional space that we're adding, they're going to be 234.6 millimeters apart, center to center. So we need to move 117.3 away from our 0 point here in either direction to be over our first hole. All right, and there is our 117.3. So we should be over our first hole now, but just as kind of an idiot check, I'm going to bring the quill down and just make sure that that lines up where I'm expecting it to be. All right, that is exactly where I'm expecting to be, so we can go ahead and center drill this first one. All right, this is a 2.5 mm drill bit. This is the correct drill bit for tapping this hole M3. The idea is we want to remove all the material where the solid part of the bolt's going to be, but where the threaded part of the bolt is, this leaves that material there. It leaves that 0.5 mm of material so that when we tap this, we cut that remaining material out in the threaded pitch for the M3 bolt for this. So, all right, let's drill this to 5 mm depth. All right, and of course the battery's dead in the Quill DRO. I hate this thing. It is like the cheapo digital calipers where every time you put them away and go back to use them again, the battery's already dead. That's this thing. I get like maybe 2 uses out of this Quill DRO and then the battery's dead. So let me go find another CR2032. I'm using genuine Sony lithium cells for this too, so it's not like I'm using cheap batteries. All right, I moved off the hole to set the 0, so I'm setting the 0 on the top of the solid surface. And now I'll just move back to our correct position on the y-axis. And now I can trust that when my Quill DRO says 5 mm, that we are at 5 mm depth. All right, I didn't feel it break through, so I think 5 was good. Let me get this cleaned up and we'll tap this before we move. All right, you guys just saw me vacuum the chips up, and I wanted to take just a second to talk about a pet peeve of mine. When I watch so many other different YouTube channels, and they're doing metalworking or woodworking or insert thing here that makes a mess, I'll often see them pull the blowgun over and just blow the chips off. And while I'll agree that that gets rid of the problem, like it cleans up the spot where you're working, you're just blowing them someplace else that you're gonna have to clean them up from. And in fact, you're often blowing them into areas that you can't even really get to clean. I don't understand why more people don't just vacuum up the chips or vacuum up the sawdust so that the problem is gone. All right, I just realized that my tap follower is not going to fit in this drill chuck. So rather than swap the drill chuck out again to tap this guy now, let's go ahead and drill the holes. Let's center drill and drill the hole on the other side as well. And then we'll switch out to a collet or a larger drill chuck to use the tap follower to tap these guys. All right, I swapped out for a tap follower, and a tap follower is just a spring-loaded, essentially like a spring-loaded center. And what that lets us do is if we have a tap handle that also has a hole at the top, and most of them do, we can put this in here, and you can see this is going to spring now. So I can bring the quill down where we are compressing that spring, lock the quill, and now this is captured in here perfectly straight up and down in both axes. So if you've ever tapped a hole and you end up a little bit crooked and then your bolt goes in crooked, this is how you avoid that. And you can do this in a drill press as well. You don't need a milling machine. I'm going to add a little bit of anchor lube. Cast iron is technically self-lubricating, but definitely does not hurt to use more lubricant. Okay, now that's a starting tap, so we probably only cut maybe the top 2 millimeters. We're going to need to switch to a bottoming tap to get to the rest of that hole. So we'll back this one out. Now this is an instance where I am going to use the blowgun to clean this out because we've got a mixture of chips and now that lube in there, and that's not going to vacuum out. You can see our threads have started really nicely in there. That's what you're looking for. All right, this looks good. I'm going to go ahead and just try an M3 screw. Yep, and that goes in no problem. All right, I'm going to do the same thing I did for this one on the other hole, and I'll bring you guys back. All right, got the second one tapped, and I cleaned off all of our marker from this, so we can go ahead and get this guy off the milling machine and back onto the lathe. All right, now as I take this off here, I do want to mention, you don't need a milling machine to do this. I have a milling machine, so that's the machine that I chose to do this in. And with the DRO, I know that these holes are exactly where they need to be, and they are tapped exactly straight. If I didn't have a milling machine with a DRO, I would have probably blued this side up, scribed it, center punched it, and done it on a drill press. And then I probably still would have tapped it in the drill press to know that I was perfectly straight up and down. If I didn't have a drill press, I'd still blue it up, scribe it, center punch it, and then just do it freehand with a drill. And the holes probably wouldn't be straight, and then I probably wouldn't tap them straight. It would probably be good enough, but I have a milling machine with a DRO, and it's satisfying to me to know that they are exactly where they should be. All right, got the cross slide back on, and I rustled up some of the correct length fasteners for each side and 2 washers as well. So unfortunately, I don't have a test piece even for this because if you remember, we moved these holes even further out than we originally planned. So I still only have that 0.4 nozzle, but I figured I'm gonna just give it another chance printing the carbon fiber one. Even if it is under extruded in places, I'd like to still be able to kind of overall just test how everything fits up now, since we do have our holes drilled in the cross slide. Now there is one other thing we have to solve for the DRO in this machine, or really I guess 2 things. Where the display is going to mount, and then also a stop for the DRO, because I discovered the other day that the travel on this lathe actually exceeds the specification that I used when I ordered the DRO scales with the backsplash off. Let me show you what I mean. Okay, so what's going to happen here is, and it's a little bit hard to see because I have the guard installed here now, but this reed head is going to run out of travel before the carriage actually stops. Now, normally this carriage runs into the backsplash. The backsplash sits like kind of right about here, and this physically hits the backsplash before this would reach the limit of travel. And when I measured everything to position it, I used that because, I needed the full travel on this end. I think we have maybe an extra 5 millimeters on that end. And on this end, I had really plenty of extra. I think I had probably 15 millimeters extra because, again, we're limited in travel here by the backsplash. Unfortunately, there are going to be instances where this lathe gets used without the backsplash. If I'm working all the way up here against the spindle, like maybe making a new back plate for a chuck or something like that, I can see needing all of that travel in this direction that I get with the backsplash off. Problem is, that reed head is going to run right into the end of the scale and it's going to break the scale. You know, if I gently crank into that stop, I can feel it, but particularly if the lathe is auto feeding or if I'm just cranking, not thinking about it, I'm going to run that reed head right into the end of the scale and break it. So what I'm thinking of doing is getting it as close to the edge as I can, maybe coming back 1 or 2 millimeters, and then figuring out what the gap is around the other side. I've got this nice convenient spot here with 2 already drilled and threaded holes. I think the reason that's there is because you can mount the, well, I'm presuming that this control box that controls, so this is how the lathe is turned on and off, is this handle here. So it's moving that shaft. Make sure I'm off. Yeah, I'm off. So as I rotate this, down is forward, up is reverse, it's turning that whole shaft. While swinging it, I don't know, maybe what's that, like 30 degrees? And you can hear like a click on this end. That's where the actual switch is. This shaft is turning and there's like a set of contacts in there that tells the control box in the back of the lathe that, hey, I want to go forward or I want to go reverse. I think that thing can be mounted on this side as well, which is why that plate is here, because I don't see what else you would use this for. But what I'm thinking we can do is, maybe we can just design a piece that sits in here, maybe goes around the shaft, that this face here would bottom out against before we run out of DRO travel. So that even if I have the backsplash off, I know that I can't physically run the carriage past the end of that DRO scale. And maybe we'll mark it like DRO as well, because if I do need to go past that stop, I could just unscrew the reed head. I mean, if I unbolt the reed head, the carriage can go off the end, no problem. And I can just, you know, bolt that back on when I'm done. So, all right, let me crank this until I'm right at the point where I can't go any further over without being off the scale. All right, that's about as close as I can get the camera in there. Hopefully you guys can see we are at the end of that scale. I don't want to risk going over any further. There's maybe 1 or 2 more millimeters of travel, but that's what I would call a comfortable limit. So let's go back around to the other side. All right, got you guys in a tripod. You can see now here is our gap here. Now that's going to be tricky to measure. I can't quite reach in there with the caliper. But if you ever see one of these at an estate sale, this is like one of those things that nobody knows what it is, and you can usually get it for like $1. Buy one, because they are great for this type of measurement. So there's a piece down here we turn, and that puts tension on this top small piece, and there's a spring in here. So if I close this, lock it down here at the bottom, bring it in, and then open it up, it snaps open, and then I can get it straight, tighten the piece at the bottom, pull it out, and it'll hold that shape. And now I just measure that with the digital caliper. All right, that is just under 50 millimeters. So, all right, let me go draw something up. I'm thinking I probably want to partially wrap around this shaft down here, but we've got to have a gap so that shaft can move. And I want to use these 2 holes that are pre-existing. So I'll get measurements of all that, and I'll bring you guys back. All right, and here is the design that I came up with for this. So I kept it pretty simple. I'm not even sure everything is gonna fit, so we'll go ahead and print one of these off and test it. But I did go ahead and mark it so that future Rich knows what this thing is. And I'm pretty sure of the position of these 2 holes here. The one that's a little bit tricky was just the distance away from that shaft to these holes while keeping a little bit of a gap so that this doesn't actually rub on that shaft. But otherwise, it is pretty much just a solid end stop. So let's go ahead and print this out and see if it fits. All right, our print is done and it came out okay. It's not perfect, but we can still use it to at least see how close we are to all of our measurements. The text came out kind of, I don't know, it's a little blurry. I think I just went too small. I'm asking too much of that nozzle to properly fill that in. And we're under extruded here a little bit, but we can still use this to see how everything fits. Well, our holes are definitely in the right position because these both went in no problem. And it looks like we're clear of that shaft. Let's give it a try. All right, so for all the measurements I took in here, I obviously did not measure the distance away from that shaft to the edge here. I thought we were going to have plenty of material for this corner to actually hit, but it's completely missing it. And I don't want to, it's hard to kind of see from the camera angle that you guys are at, but it's if I was able to keep cranking this way, this block here, this face would go right past this piece here. So we clearly need to make the diameter of this bigger. But I think that is probably it. Otherwise, it looks good. Let me get this out of the way and just check everything else. All right, everything else looks good with this. We have a gap here for the shaft, so we're not rubbing on it. And I say we have the right amount of clearance. I can force it to touch in any direction if I want, but it's staying right there with that gap. Our screw holes are in the right place. I think I'm going to get rid of end stop and just have DRO here a little bit bigger. That'll still remind future Rich what this thing's doing here and what I need to go change in the back should I want to remove this to bring that carriage over further. And I think I'll increase the size of this whole base here as well since we're increasing the size of this. So let me go make those changes and I'll bring you back. All right, our new one is finished and this looks so much better, particularly on the lettering. We don't have any under extrusion issues. And I think I'm going to stick with this blue. I was trying to kind of get close to the color of the lathe. It's definitely a brighter blue than that, but still looks good. So let's get this one off and see how this one fits. All right, that fits on there really well. We still have a good clearance here on the shaft. And I don't know, from a size perspective, this just looks like it belongs there better than the other one anyway. But let's crank the carriage over and see if it actually works. Yep, yeah, right into it. We've got a decent overlap there now. I can feel it as a hard stop on this wheel when I come into it. Let's see where we are in the back on that sensor. We got a little bit of room to go. We could probably go another 2 or 3 millimeters, but that's perfect. I like leaving just a little bit of room for safety so I don't crash that head. All right, well, our updated DRO mounting piece finished, but surprise, surprise, it also has under extrusion. There's some there, there's some here on this other side, and there's some here at the bottom again. So I'm not gonna be able to use this, but we can certainly test with it. So let me get the nuts pressed in, all 4 of them, and we'll see if it fits. Let's try actually mocking up the DRO and the cover. Let's try our wrench here before I put the cover on. Yep, definitely have plenty of swing for the for our bolt there, for our locking bolt for the cross slide. All right, well that all mounted up really nicely. We are just below the top face of this now. I didn't put an indicator on this and adjust it yet. We'll need to go, once I have the final piece done, we'll need to make sure that this isn't on any type of an angle in this direction or in this direction. So it might need to be shimmed or might need to just be sanded down on one side. But mocked up, I mean, that definitely looks good. There's plenty of clearance down here for the reed head. I already confirmed that full travel from front to back with the reed head centered in the casting down here will work. And if I go around the back, you can see we have plenty of room for the cable underneath there. In some of these DRO installs, I've seen guys actually mill out part of the carriage for this to clear. If you go with the small DRO, you've got plenty of room there for it to go through without actually milling away any of the material of your carriage. So yeah, all that's left to do on this is, I mean, the design's final. We just need to actually get a successful print without any under extrusion in the right material. And this is the PA6 CF. I tried to get the PET CF, which I think would be the better solution for this. You guys mentioned that down in the comments as well. in last week's video and the week prior to that, but you can't get it. It's on Bamboo's website, it's listed as back in stock like the end of this month, which is a pretty good distance away. So I don't know, I may actually finish mounting this up with this one. I hate to go through all the work of tramming this in to take it all apart to tram it all in again, but I guess I could at least measure and figure out where that bottom one is going to need to mount. We also still have to figure out how to mount the touch DRO display. I'm tentatively thinking about making a new block here that allows for a second piece of pipe to come up and mounting it on that, similarly to how we mounted this guy. It'll just be much smaller, but we'll do another mount like this where it attaches to the pipe at the bottom, and then we can just lock that phone in that I'm using for touch DRO on the lathe. Yeah, here's a hunk of just hollow aluminum tube. I mean, even that would probably work if we had a way to get two pipes into this. And then we just have one of these guys, either, maybe we have probably have the pipe come up along behind it. So it's a nice stiff rigid mount. I mean, all we're holding is this small little phone that I'm using here for touch DRO on the lathe. And the idea then will be, imagine it's so parallel to this, but maybe like up this high, and it just travels back and forth with the carriage. All right, guys, we finally made some more progress on this, and I'm really happy with the stop for the DRO. Now I don't have to worry about forgetting about that when the backsplash is off and just cranking this guy right into the end of the scale. And that looks pretty good mocked up. I think that is going to work with no further modifications to the design itself. We just need a successful print in the right material. Guys, as always, thanks for hanging out in the shop with me for this week's prints and design work. If you got anything out of this at all, take a second, hit that like button. It really helps out the channel. Also helps you out too. It tells YouTube the kind of videos you like, so it'll show you more stuff like what you're seeing in this video. And if this is your first time on the channel by chance, I do a new functional print every single Friday. It's often out here in the shop, but I do stuff in the house and outside as well. So if this is your first video, check out some of my other ones. And if you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.